So that's one very practical application.
Absolutely.
And what other nanotechnology products have been produced so far?
Very interestingly, probably the largest application of nanoparticles and nanotechnology is in the paint industry. Probably the largest market for nanoparticles is particularly in the field of wood preservatives, whereby the major paint manufacturers have discovered that the actual reducing the size of what might be broadly called conventional materials gives vastly improved performance in terms of aging, wear, and resistance to fungi.
And you were saying that earlier that Nature magazine had said that this was a $1 billion industry?
This is a $1 billion industry, yes.
But quite prosaic, isn't it?
Prosaic, it's very, very unsexy, but it makes money. And at the end of the day, nobody is going to actually sort of take up the use of nanotechnology unless it provides what is sort of a huge economic benefit, because these materials are not inexpensive.
So which companies are focused on nanotechnology development?
Certainly, in terms of production of nanotechnological materials, certainly Evonik in Germany and Altana in Germany are very, very active, and there is an awful lot of work actually also being carried out in the Far East, in Japan, Korea, China. A particular example, probably Nissan in Japan.
Right. And there are other Japanese companies, and you were saying earlier, Mitsubishi was.
Mitsubishi actually are also closely involved in these areas.
So it's two sets of car companies, presumably looking at the paint for.
Indeed, and also rather interestingly, the actual sort of for actually coatings on headlamps. So if you can imagine a headlamp, whilst it sort of might become very, very easily damaged, so a lot of them, in fact, are not actually using glass these days, but actually polycarbonate, hard-coated polycarbonate, rather like sort of some glasses lenses. But the use of abrasion-resistant coatings in the automotive industry is very well understood. And as I say, Mercedes-Benz, BMW, people like that are very, very involved.
And American companies, you were naming 3M. Any others?
3M certainly are involved in this particular area. But it's an interesting comment, an interesting thought that in fact, and we discussed this earlier, that people or manufacturers these days are perhaps a little less sort of open in actually saying that their material, their products actually contain nanomaterials. And as I say, we can probably discuss the reasons for this a little later.
And where's the academic expertise for nanotechnology?
Well, certainly in the UK, so there's an awful lot of interesting work actually has been carried out at the University of Manchester. But Gaiman, sort of, I think, is how you pronounce the sort of the name. Of course, won the Nobel Prize for the work that they actually carried out with graphene. Certainly, Manchester is a very strong hub of activity, specifically in graphene. But there's an awful lot of work actually being carried out worldwide. I think that again, a survey carried out in Nature some time ago indicated that most of the most patents and actual research papers are actually published out in the East, actually Japan, China, South Korea. Certainly work's also been carried out in the US. So it's sort of overlooked the US a little bit.
But that's also partly to do with the chemical plants.
Indeed, there's been a huge migration of sort of large-scale technology out east. It's as I say, which I have my own thoughts on, but that's discussion for another day. But certainly an awful lot of technology actually moved that way, which I think will actually help drive the sort of the development of nano industries within the Far East.
And what's the gap between idea and product? Because it seems to me that the promise is in quite sort of prosaic.
This is an item that I could talk about for a long, long time. The actual gap between promise and delivery is very large. The great problem of nanotechnology is not actually the development of materials within the laboratory. It's the actual scale-up from gram scale to kilogram scale. Most industrial applications require large amounts of material produced consistently. And it's the actual scale up from the lab bench to the production plant that is the huge difficulty that actually confronts the nanotechnology industry today.
And typically, what goes wrong?
What goes wrong is simply that people do not understand the problems of scale up. It's producing a few grams of material in a test tube is fine, but to be able to do that consistently within a end user's what's its sort of requirements is a huge challenge. Many people sort of look at actually sort of think they can produce a dispersion of nanoparticles quite readily, but the actual physics of actually ensuring a stable dispersion is very difficult.
What are the materials that the nanoparticles are contained in?
Essentially, sort of nanoparticles. The nanoparticles are legion, but they can be dispersed essentially within water, organic solvents such as alcohol, or rather more exotically, organic chemicals that can be cured by UV light. So in fact, there is actually sort of no volatile ingredient within the actual formulation, provided
it's cooked, inverted commas.
It's mixed. Yeah. It's mixed, but if you don't get the mix right, instead of a nice, even, smooth flowing dispersion, you get a solid lump.
Yeah.
And nobody likes working with solid lumps.
And that is because it's very difficult getting the proportions right at nanoscale, or getting the controlled environment.
It's understanding the actual physics and chemistry.
Right.
There are still huge challenges to actually be overcome. It's essentially nanoparticles are about surface, and it's the actual coverage of that surface and how strong the actual stabilizing agents are on the surface. Left to their own devices, nanoparticles would not remain nano; they would just clump together.